Example 2.232. If the position vector of the particle is given by r is equal to 3t square I vector plus 5t j vector plus 4k vector, find the velocity of the particle at t is equal to 3 seconds. Then speed of the particle at t is equal to 3 seconds. Acceleration of the particle at t is equal to 3 seconds. Okay. Now what is given here is the position vector is given. R vector is equal to 3t square I vector plus 5t plus 4k vector. Now first we have to find out the velocity. Velocity is equal to dr by dt. That is d by dt of 3t square I vector plus 5t j vector plus 4k vector. Now we are going to differentiate. Differentiation of 3 is a constant, so we can write it. Differentiation of t square, it is 2t. 2t into I vector plus 5 into differentiation of t is 1. 1 into j vector plus 4 into 4 is a constant. Differentiation of 4 is a constant. So it is 0. 0 k vector. So this can be written as 6t I vector plus 5 j vector. Now what is asked in the problem is velocity at 3 seconds. Velocity at what? 3 seconds. So velocity at t is equal to 3 seconds is equal to, substituting 3 for t. Okay, so we can write 6 into 3 I vector plus 5 j vector. So it is 18 I vector plus 5 j vector. Okay. Now what is your second part? Second part is speed of the particle at t is equal to 3 seconds. So what is speed? Speed is magnitude of velocity. Speed is what? Magnitude of velocity. So magnitude of velocity. Velocity at 3 is equal to t second. T is equal to 3 seconds is 18I plus 5j. Now so velocity is equal to velocity at so now speed is equal to speed at t is equal to 3 seconds is equal to root of vx square plus vy square. That is 18 square plus 5 square. So what is 18 square? That is 324 plus 25. That is equal to root 349. Which is, what is root 349 is 18.68. What is the unit for speed? That is meter per second. Is what? Meter per second. Now the third part of the problem is we have to find out the acceleration at t is equal to 3 seconds. Now the first derivative of the position vector is velocity. The second derivative of the position vector is acceleration. The second derivative is what? Acceleration. So acceleration is equal to A is equal to d square r by dt square, or we can write d by dt of dr by dt, or we can write it as d by dt of dv by d by dt of, here what is dr by dt? Dr by dt already we found out, 6t I vector plus 5j vector. Now we are going to differentiate this again. So when you are going to differentiate it, 6 into differential of t is 1. 1 into I vector plus 0. 5j vector is what? 0. So what is your acceleration? Acceleration is equal to 6 I vector. Okay. Now what is acceleration at t is equal to? Acceleration at t is equal to 3 seconds. Here there is no t conduct. Okay. There is no t value. So the same value. Acceleration is equal to how much? 6 I vector. Okay. So we can find it out. That is, the acceleration is constant, but the velocity is not a constant one. Okay. So that we can say the velocity is non-uniform, but the acceleration is in uniform.